Okay. See, we are discussing regarding when the transformer on load condition. That means when load it should be put on the secondary of the transformer. Then there is some current. It will be start from secondary side. And the load characteristics it should be depends upon types of load it can be connected. So there are three types of load, that is resistive load, inductive load, and the capacitive load. Okay. So if the purely resistive load it can be connected, then the current flowing from secondary side it is in phase with that of voltage. If there are purely inductive load is there, then the current flowing from secondary side it is lag behind by voltage exactly 90°. And if the purely capacitive load is there, then the current flowing from secondary side it will be leads behind by leads the voltage by an angle exactly 90°. So that means the load characteristics it should be depends upon types of load characteristics. It should be depends upon types of load. See, when the secondary circuit it can be closed, that means a load it can be connected to secondary side. There should be some of the current it will be start flowing. See here it is diagram it can be shown. Ito diagram दाखवली बघा. So in case of this transformer, if the load it can be connected on the secondary side of the transformer, that means somewhat load it should be putted in between this secondary winding. Okay, secondary winding चे जे काही दोन टर्मिनल आहेत त्याला आपण काय केलं, एक लोड कनेक्ट केला. Whether it may be resistive load only, whether it may be only inductive load, or it may be RL load, or it may be RLC load. So whether resistive, inductive, or capacitive, the characteristics it should be depends upon types of load. कोणत्या टाइप्स ऑफ लोड कनेक्ट करतोय त्याच्यावरती काय रे डिपेंड आहे. Now see when this current it will be start flowing from this secondary side, and this current it will be set off by the EMF induced due to secondary ना जे काही induce केलेला EMF आहे, due to that secondary induced EMF the current it will be start flowing from secondary side. See, this secondary current, suppose we are representing this is the IS current which is determined by the characteristics of the load characteristics नुसार determine केला जाईल. So load characteristics it will be create a self induced secondary magnetic field phi s in the transformer core which flow exact opposite direction to that of main primary field. I will explain this by using a diagram in the next slide. See, but all of you understood. Due to that current, when the current it will be start flowing from secondary winding, what will happen? काय होईल? आपण नो लोड मध्ये बघितलं सेकंडरी साइड मधून फ्लो होणारा करंट काय होता, 0 होता. But in case of this on load condition, the current flowing from this secondary side is nothing but IS. When this current it will be start flowing from this secondary winding or secondary winding मधून हा करंट फ्लो व्हायला स्टार्ट झालाय, what will happen? First effect काय होईल, सेकंडरी वाइंडिंग मध्ये जर करंट फ्लो व्हायला स्टार्ट झाला तर
flux is generated.
That means it will produces a flux in the which winding, whether it is primary or secondary.
Secondary.
That means when the current flowing from the secondary winding, due to that current it will produces some of the flux. ते काय करेल, काहीतरी flux produce करेल. Okay, now see, due to that value of flux it will induces some of the EMF in the secondary winding. Do you know that according to the working principle, if the current flowing start from any winding, there is some flux it will be produces. Due to that flux there is some of the EMF it will be induces. So according to EMF equation it is depends upon flux. I think we have derived EMF equation. Suppose E is equals to 4.44 EF phi m into N. So it is having an N number of turns. It is having an flux phi m, frequency of supply EF and 4.4. So frequency and this EF frequency and this 4.44 get cancelled, or it may be constant. So E is directly proportional to phi into N. Again N, that is number of turns of the transformer, it is also constant, so that induced EMF it is directly proportional to phi, right? So see, if the flux it will be created by that of secondary current, Due to that, some of the EMF it will be induces in the secondary side. Secondary side मध्ये काय होईल, काहीतरी EMF induce होईल. All of you keep in mind. But this induced EMF, okay, but this induced EMF, that is this flux, it will be induces some of the EMF, and this flux phi, it is created in the opposite direction to that of primary flux. I will explain this by using a figure, but you people understand the concept. Do you know that when the supply it can be given to that of primary winding, there is some of the flux it will be created. This flux it will be links to that of secondary side. There is some of the EMF it will be induces in the secondary side. Secondary side having and some load it can be connected, so that some current it will be start flowing from secondary side. Due to that current, it will produce some of the flux in the secondary side. But this produced flux, it is in opposite direction to that of main flux. It is in opposite direction to that of main flux. So these two magnetic field oppose each other, and the resulting in a combined magnetic field of less magnetic strength. So this flux it will be created, and it is in opposition to that of main flux. So it will distort the value of main flux, or it will be decrease some of the main flux. Main flux काय होतील, decrease होतील. That means resultant value of flux it will be reduces. Okay, resultant value of flux it will be less strength than that of single field, that of a single field produced by the primary winding alone when the secondary circuit was open circuited. Okay, now this combined magnetic field it will reduces the back EMF of the primary winding. It will be causing a primary current IP to increase slightly. काय होतं परत बघा, त्याच्यामुळे resultant value of flux decrease झाली. So do you know that resultant value of flux it will be decreases, so the induced EMF it will also decreases according to this relation. And if the induced EMF it will be decreases, that means back EMF produced it is decreases. So if the back EMF it will be decreases, then the transformer it will be take a more primary current. Transformer it will take more primary current, or current taken by the primary it will be slightly increases. The primary current continues to increase until the core magnetic field is back at original position, or it may be original strength. So it will be increasing, or it will be start increasing up to when the EMF induced and the supply voltage remains in equal. Up to that, the current taken from the supply it will be increases. So for the transformer to operate correctly, a balanced condition must be always exist between the primary and secondary magnetic field. So the resultant or result in the power to be balanced. जो काय पॉवरचा रिझल्ट असेल, power in the primary winding, or it may be power in the primary circuit and power in the secondary circuit remains same. See here the sentence is given, that is balanced power and the same on the both primary and secondary side. So for that consider this one. I will explain this in detail. So here the power equation it can be given, power at the primary it is
Sir,
equal.
voice is not audible.
Just it is breaking or totally not audible?
Sir, now is audible.
Now audible, no?
Yes.
I have connected mobile internet, so that there is some problem. Now clearly audible, no?
Yes, yes, sir.
Okay. See, to make the balanced power, or it may be to power remains same in the both the side, that is primary and secondary. So to make that balanced power, it will increase the current taken from the primary. So that equation becomes voltage primary into current primary. It is nothing but power at the primary side. It is equals to voltage secondary into current secondary. That means power at the secondary side. So according to this, Vp into Ip divided by Vs is equals to Is. So according to this, we got this equation. त्याच्यावरून एक equation मिळेल. Now we will discuss this same concept by using some diagram. Okay, so see, this one is the first diagram. See, we have already discussed when the transformer on no load condition, ज्यावेळेस transformer no load condition ला होता, it will set up some of the flux because we are providing some supply to the top primary winding. Primary winding ला आपण काय करतोय, काहीतरी सप्लाय प्रोड्यूस करतोय, सॉरी सप्लाय देतोय. So if the supply it can be given to the top primary winding, so if the secondary winding it is open circuited, some current it will be start flowing from primary side. बरोबर, प्रायमरी साइड मधून काहीतरी करंट फ्लो होतो. यस, हॅलो, गिव मी रिप्लाय.
Yes, sir.
Okay, see, in case of no load condition, that means when the transformer it is on no load condition, ज्यावेळेस transformer no load condition ला आहे. So I have drawn here diagram. If the transformer on no load condition, at that situation, to fulfill the or to overcome the no load losses, there are some current it will be taken from the supply. So transformer it will take some of the current, that is I0 current it will be taken from the supply. Supply कडून I0 amount of current काय केला जातो, transformer घेतला जातो. See, due to current flowing from this primary winding, it will set up some of the flux phi. It will be shown. This flux phi is nothing but current set up due to that no load current I0. I0 na set up केलेला current. Okay. Now consider when the transformer is on load condition. That means when the transformer it is loaded. Transformer it is loaded, that means on the secondary side there is a load connected.
Yes, sir.
When the secondary side there is a load connected, that means the current it will be start flowing from secondary side. Secondary side मधून काहीतरी current flow व्हायला start होईल. So this current I2 it is nothing but it will be start flowing from this secondary side. See, when this current I2 it will be flowing from the secondary winding, then when the current it will be start flowing from secondary winding, it will produce some of the flux, right? बरोबर ना?
Yes, sir.
When this current it will produce some flux, but this produced flux it is in opposite direction to that of main flux. Consider लक्षात घ्या मी काय सांगतोय. See here, direction is also given. Due to this primary current or the no load current, it will produce some flux. So it is shown by this phi. हा phi ने दाखवलेला flux जो आहे, so it will be flowing in this direction. Direction बघा. Suppose this it will be flowing from clockwise direction. Direction is given. Now see, when the secondary it is loaded, that means secondary circuit it can be closed. There is some of the current it will be start flowing from secondary side. When the current start flowing from secondary side, due to that current in the secondary winding, it will produce some flux. But this produced flux it is in opposite in direction to that of main flux. हा phi जो आहे तो मेन फ्लक्स आहे, सप्लायच्या करंट मुळे फ्लो झालेला किंवा प्रोड्यूस झालेला. This I2 it will produce some flux. Suppose this I2 it will produce a flux phi 2, but it will be produced in opposite direction. See, हा जो काय फ्लक्स आहे तो phi 2 न प्रोड्यूस केलेला आहे, that is I2 न, but it is in opposite direction. Getting this point? हे लक्षात आलं का इथपर्यंत?
Yes, sir.
See, when the circuit it can be loaded, then the secondary current it will be start flowing from secondary side, or some of the current it will be flowing from secondary side. When the current it will be start flowing from secondary side, it will produce some flux in the that means core, that is phi 2 flux, but it is in opposite direction. हा जो काय flux आहे, so this flux it will be produced in the opposite direction. See, now this flux it will be produced in the opposite direction. That means it will weaken the value of main flux, or it may be it will distort the value of main flux. Main flux ला तो काय करेल, अपोज करेल. बरोबर? Getting what I am telling? So one flux, it will be flowing from this direction, that is this one is the main flux phi, and some flux it will be produces in the opposite direction. So this flux, it is nothing but phi 2. So this flux produced due to that of secondary winding current, it will be opposite to that of primary flux. So that means it will weakens the value of main flux. Main flux च्या value काय करेल, ती weak करेल किंवा distort करेल. Getting? लक्षात येते का मी काय सांगतोय? काय होतं, तो ऑपोजिट डिरेक्शन न फ्लो झाल्यामुळे प्रायमरीचा करंट काय होईल किंवा प्रायमरीचा फ्लक्स जो आहे तो रिड्यूस होईल, कमी होईल. सो दॅट द रिझल्टंट व्हॅल्यू ऑफ फ्लक्स इट विल बी रिड्यूसेस. Resultant value of flux it will be reduces. Now if the resultant value of flux it will be reduces, what happen? According to this equation, E is equals to E is directly proportional to phi. If the resultant value of flux it will be reduces, what about induced EMF in the primary side?
Reduces.
So induced EMF in the primary side it will be also reduces. Okay. Now see, I will show the second figure. In that, see here, the induced EMF in the secondary primary side it will be reduces. If the induced EMF goes on decreasing, at that moment when the induced EMF it will be goes on decreasing, the voltage supplied at the primary side, that is V1, it will take upper hand to that of E1. म्हणजे बघा, सप्लाय करंट जर 230 असेल, कन्सिडर करा. Suppose supply current is 230. Okay, supply voltage it is 230. Due to that supply voltage, I0 current it will be flowing from suppose 2.5 ampere, or it may be considered a 3 ampere. Due to that some flux phi it will be produces. त्याच्यामुळे काहीतरी flux phi काय होतात, produce होतात. Now when the secondary side it will be closed, that means secondary side it is loaded, but upon this flux it will be links to that of secondary. There is some of the EMF it will be induces in the secondary side. When this EMF it will be induces, it will set up some of the current. When this current it will be flowing from the secondary side, so due to that current it will produces some flux, but this flux it is in opposite direction. Opposite direction मुळे काय होतील, flux produce होतील. See, if the flux produced in the opposite direction na flux produce झाले, it will weaken the value of main flux. That means it will be distort the value of main flux. Hence the resultant value of flux it will be reduces. If the resultant value of flux it will be reduces, ज्यावेळेस resultant value of flux reduce होईल, automatically the induced EMF at the primary side it will be decreasing, right? बरोबर का? Hello?
Yes, sir.
Induced EMF at the primary side it will be decreases. See whether there is any effect on supply voltage. सप्लाय व्होल्टेज वरती काय इफेक्ट होतोय का, इंड्यूस्ड ईएमएफ कमी झाल्यानंतर? दॅट मीन्स सप्लाय व्होल्टेज इट विल बी गोज इन अप्पर हँड ओव्हर द E1, and due to that बघा सप्लाय व्होल्टेज सेम राहील, इंड्यूस्ड ईएमएफ डिक्रीज होईल. To meet the power equal or to make the voltage equal, so additional amount of current it will be taken from the supply. काय होते बघा, when the EMF induced in the primary, that is EMF induced in the primary side, it will be start decreasing. At that situation, to meet the value equal, that is V1 and E1, the current taken from the supply it will be increases, that is the transformer it will take additional current from the supply. Getting? So see, and this additional current which is nearly equal to that of secondary current. Okay, to meet this value, at that time the additional current it will be taken from the primary, that is from the supply, and this additional current it is nearly equal to that of secondary current, so that the transformer it will take one extra amount of current, that is additional current I2 dash from the primary side. लक्षात आलं? हॅलो, हा, yes, give me reply.
Yes, sir.
सी स्टेप लक्षात ठेवा. पहिली स्टेप आपण नो लोडची कंडिशन केली आहे. नो लोड मध्ये करंट ट्रान्सफॉर्मर इट विल टेक अ करंट फ्रॉम द सप्लाय. At that situation there is a no secondary current, it will be start flowing. Okay, so this no load current it will be produces some of the flux. तो काय करतो, काहीतरी फ्लक्स प्रोड्यूस करतो. It is shown by phi. Okay, suppose it is in the clockwise direction. Now when the secondary it is loaded, that means the current flowing from secondary side. If the current start flowing from secondary side, this current it will be set up some of the flux in that winding. त्या वाइंडिंग मध्ये तो काहीतरी फ्लक्स प्रोड्यूस करतो. So this flux it is also travel from secondary to primary, but this produced flux it is in opposite direction to that of main flux. Main flux च्या opposite direction मध्ये असेल. So due to that it will reduces the resultant value of flux. Resultant value of flux ची value काय will reduce will. If the resultant value of flux it will be reduces, so automatically the induced EMF at the primary side it will be start decreasing. Induced EMF at the primary side it will be start decreasing. That means induced EMF in the primary side, that is E1, it will be start decreasing. And when the E1 it will be start decreasing, that means a voltage V1 it will as upper hand to that of E1. Voltage जे आहे सप्लायचं ते upper hand ला असेल E1 च्या. So this will cause, due to that it will cause it will draw an additional amount of current from the primary. प्रायमरी कडून तो काय करेल, ऍडिशनल अमाउंट ऑफ करंट घेईल. दॅट मीन्स दिस करंट इट इज नियरली इक्वल टू दॅट ऑफ सप्लाय करंट. सो दिस करंट इट विल बी रिप्रेझेंटेड बाय I2 डॅश. I2 डॅश न रिप्रेझेंट केलेला जो काय करंट असेल. सो दिस इज द एक्स्ट्रा अमाउंट ऑफ करंट और ऍडिशनल करंट टेकन फ्रॉम द प्रायमरी टू मीट द व्हॅल्यू V1 इज इक्वल्स टू E1. राईट, to meet the value V1 is equals to E1, or to restore the value V1 is equals to E1, it will take additional amount of current from the primary side. That is I2 dash current it will be taken from the primary side. Okay, now see again this I2 current it will be flowing from primary winding. परत I2 current काय होतोय, प्रायमरी वाइंडिंग मधून फ्लो होतोय. हॅलो, give me reply. That I2 current it will be start flowing from this primary winding, and at this I2 it will be again set up some of the flux in the primary winding. I2 काय करेल, काहीतरी फ्लक्स प्रायमरी वाइंडिंग मध्ये काय करतोय, सेटअप करतोय. नाउ सी I2 it will be produces some of the flux in the primary winding. So this flux it will be shown by the phi2 dash, but it is in the same direction as that of main flux. हा जो काय फ्लक्स असेल इट विल बी इन द सेम डिरेक्शन ऍज दॅट ऑफ मेन फ्लक्स. मेन फ्लक्सच्या सेम डिरेक्शन ना काय होईल, प्रोड्यूस होईल. अँड दिस फ्लक्स इट विल बी न्यूट्रलाइज द इफेक्ट ऑफ फ्लक्स प्रोड्यूस्ड बाय सेकंडरी करंट I2. बघा, सी हियर, सी दिस phi it is nothing but flux produced by supply current. हा जो काय phi आहे तो फ्लक्स प्रोड्यूस्ड बाय सप्लाय करंट. सो इट इज इन दिस डिरेक्शन, याची डिरेक्शन क्लॉकवाइज आहे. ज्यावेळेस सेकंडरी मधून काहीतरी करंट फ्लो व्हायला स्टार्ट होतोय, इट विल सेट अप सम ऑफ द फ्लक्स इन द सेकंडरी वाइंडिंग. सो बट इट इज इन अपोजिट डिरेक्शन, सो दॅट दिस phi2 करंट इट विल बी फ्लोइंग अँड इट इज इन अपोजिट डिरेक्शन. याची डिरेक्शन कोणते, अपोजिट डिरेक्शन. ओके, so to meet the value of E1 is equals to V1, that means to meet the supply voltage it is equals to induced EMF at the primary side. The additional amount of current it will be drawn from the supply, or a transformer it will draw an additional amount of current from the supply. So this additional amount of current it is nearly equal to that of I2. That means it is represented by I2 dash. So I2 dash current it will be taken from the supply. Supply कडून काय केला जातोय, I2 dash current घेतला जातो. Now see, if this I2 dash it will be taken from the supply, and when it is start flowing from this primary winding, ज्यावेळेस तो प्रायमरी वाइंडिंग मधून फ्लो व्हायला स्टार्ट होईल, it will also set up some flux, right? So suppose this phi2 dash it will be flux set up due to the current I1, due to current I2 dash. I2 dash करंट मुळे या ट्रान्सफॉर्मर मध्ये phi2 dash फ्लक्स सेटअप होतो. बट दिस फ्लक्स phi2 dash it is in same in direction to that of main flux. Main flux च्या तो काय असेल same direction ना असेल, right? No, it is in the same direction as that of main flux. बघा याची direction हा phi2 dash आहे, it will be produced by that of I2, and direction of this it is nothing but clockwise direction, right? See this phi2 dash, it will be neutralize the effect of phi2. phi2 म्हणजे सेकंडरी करंट मुळे प्रोड्यूस होणारा जो काही फ्लक्स आहे त्याचा इफेक्ट न्यूट्रलाइज करण्यासाठी एक्स्ट्रा अमाउंट ऑफ करंट इट विल बी टेकन फ्रॉम द सप्लाय, and due to that current there is some flux it will be produces, that is phi2 dash. phi2 dash flux काय होतील, प्रोड्यूस होतील in the transformer. Okay, so see, then if this effect of phi2 it will be neutralized by this phi2 dash. हा जो काय इफेक्ट आहे phi2 dash चा इफेक्ट जो आहे जर phi2 dash न न्यूट्रलाइज केला, that means again it will neutralize the effect of flux produced by that of secondary current. So in the transformer the resultant flux it will becomes only resultant flux it will be remains. So I will show this resultant flux by using a diagram. Here it is, this one is the resultant flux. See, only resultant flux it will be flowing from this transformer. So and the current taken from the primary it is nothing but I1 current, and the current flowing through the secondary it is nothing but I2 current. Now see, the current flowing from the primary, again it is the vector sum of two current. Current flowing through the primary winding, it is again the vector sum of two current, that is it is the sum of I2 dash and I0. So I will write here I1 bar it is equals to I0 bar plus I2 bar. I1 bar, that is vector sum of these two current. या दोन करंट ची जी काय वेक्टर सम असेल I2 dash ची आणि I0 ची, right? So vector sum of these two current, that is vector sum of I2 dash and I0, it is nothing but total current taken from the primary. So total current taken from the primary we can represent here I1, that is I1 or total current taken from the primary, it is nothing but I1 current taken from the primary, and it is the vector sum of no load current of the transformer and additional amount of current taken from the supply, that is transformer na घेतलेला additional current. So the resultant value of flux, जर हा phi2 चा effect phi2 dash na neutralize केला, okay, if this effect it can be neutralized, only which flux it can be remains, कोणते flux राहतील? Phi is nothing but main flux. Only main flux it will be remains, because we are neutralizing effect of flux produced due to the secondary current. Secondary current मुळे प्रोड्यूस होणारा जो काही फ्लक्स आहे त्याचा इफेक्ट आपण काय करतोय, न्यूट्रलाइज करतोय. ओके, वी आर न्यूट्रलाइजिंग द इफेक्ट ऑफ करंट प्रोड्यूस्ड flux produced due to that of secondary current. We are neutralizing that effect by taking additional amount of current from the primary side. So the primary current it is equals to, it is the vector sum of no load current plus additional amount of current, that is I2 dash. Okay, additional amount of current it will be I2 dash. Okay, now see, and this whole process it will be start at the instant when the transformer it is loaded, or it may be when the load it should be putted on the transformer. ही जी काय प्रोसेस आहे ती कधी स्टार्ट होईल, ज्यावेळेस सेकंडरीचा करंट फ्लो व्हायला स्टार्ट होईल. सेकंडरीचा करंट कधी फ्लो व्हायला स्टार्ट होईल, ज्यावेळेस सेकंडरी साइडला लोड पुट केला असेल, राइट? सो सी the net flux or the resultant value of flux when it is loaded, it is only due to that of primary, that is only due to that of primary current or I1 current, and which is the same as that of no load condition. So no load condition मध्ये बघा आपण बघितलं, that is I0, it is no load current, it is equals to, it is the vector sum of two component or two current, that is IW plus I mu. IW plus I mu. And similarly, in case of transformer, it should be putted on load. ज्यावेळेस ट्रान्सफॉर्मर लोडला पुट केले, again the supply current or it may be primary current taken from the supply, that is I1 bar, it is equals to, it is the vector sum of no load current plus additional amount of current taken from the supply, that is I2 dash current. So see, from these two, that is no load condition and full load condition, or it may be load condition, we can conclude that whenever will be condition there, either it may be load or it may be no load, the operation of the transformer, it will be same. What is the conclusion from no load and full load? That means the operation of the transformer, it will be same, either it may be load condition or it may be no load condition. That means current taken from the supply, again in case of no load, it is the vector sum of two component, and the current taken from the supply in case of load condition, again it is the vector sum of two component or the two current. But in case of load condition, I1 bar, it is equals to I0 bar plus I2 dash bar, and in case of no load condition, I0 bar is equals to IW plus I mu. Okay, so this is the conclusion regarding no load and full load condition, or it may be load condition, and only the resultant value of flux, it will be remains in case of this secondary. Okay, in case of this secondary or in case of this load condition. Okay, getting operation, लक्षात आले का operation? Whether all of you understood the operation? If you seen only this figure, then you can't understood anything. I am telling already by step, that means you people are understood. लक्षात आले का तुमच्या? Hello, can I explain once again in few minutes?
Yes, sir.
Okay, see, लक्षात घ्या, कंडिशन काय आहे, ट्रान्सफॉर्मर आपण लोडला पुट करणार आहे. we have already discussed regarding when transformer it should be putted on no load. ज्यावेळेस नो लोडला पुट करतोय त्यावेळेस करंट इन द सेकंडरी साइड इट विल बी 0. सेकंडरी साइडचा करंट काय आहे, 0 आहे. at that situation transformer it will take some amount of current I0 from the supply कडून तो मिनिमम अमाउंटचा करंट किंवा स्मॉल अमाउंट ऑफ करंट घेतो टू ओव्हरकम द लॉसेस. that means it will take some amount of current from the primary. Suppose we have represented this current taken from the primary, it is nothing but I0. त्यानं I0 current घेतला primary कडून, आपण असं consider करू. Okay, so see here it is I0 current taken from primary. When this I0 current it will be start flowing from this primary winding, it will set up some flux, right? हे लक्षात आलं? फास्ट गिव्ह मी रिप्लाय.
Yes, sir.
नो लोड करंट मुळे काय होईल, काहीतरी फ्लक्स सेटअप करेल. हा फ्लक्स कुठं फ्लो होतो, इट विल लिंक टू द प्रायमरी एज वेल एज सेकंडरी. सेकंडरीला पण लिंक होईल, प्रायमरी मध्ये काहीतरी ईएमएफ इंड्यूस होईल, and again in the secondary side there is also some of the EMF it will be induces. Secondary side ला पण काहीतरी EMF induce होईल, but there is a open circuit so that no current flowing from secondary side. बरोबर, in no load condition सांगितलं. Now see, when the transformer is on load condition, म्हणजे ट्रान्सफॉर्मर आता काय केला, लोडला पुट केला. that means the secondary side it is loaded. secondary ला काय करतोय आपण, लोड पुट करतोय. when the secondary it is loaded, that means some current it will be flowing from secondary side. सेकंडरी साइड मधून काहीतरी करंट फ्लो होईल, राइट? Yes, give me reply. If the secondary is loaded, that means some current it will be start from flowing from secondary, right? No?
Yes, sir.
If the current flowing from secondary winding मधून current flow व्हायला लागला की काय होईल, it will also set up some flux. त्याचे पण काहीतरी फ्लक्स प्रोड्यूस होतील किंवा काहीतरी फ्लक्स सेटअप होईल, बट दिस फ्लक्स इट विल बी प्रोड्यूस्ड इज इन अपोजिट डिरेक्शन टू दॅट ऑफ मेन फ्लक्स. मेन फ्लक्सच्या काय असतील ते अपोजिट डिरेक्शन नसतील. सी, phi produced in this direction, clockwise direction, and phi 2 produced in this opposite direction. Okay, see, त्याच्यामुळे काय होईल, if the phi 2 it will be produces in the opposite direction, it will distort the main flux. मेन फ्लक्स ला काय करेल, तो डिस्टॉर्शन करेल. किंवा त्याची व्हॅल्यू वीक करेल. वीक करेल म्हणजे कमी करेल थोडक्यात. कन्सिडर करा, if the main flux value it will be weakens, automatically the EMF induced in the primary it will be reduces. बरोबर ना? Hello?
Yes, sir.
That means EMF induced in the primary side it will be reduces, that is E1 it will be start reducing. So to meet the value V1 is equals to E1, we want to meet this value, that is supply voltage, it is equals to E1. That means we want to restore that value V1 is equals to E1. It will take some additional amount of current from the primary. ती व्हॅल्यू मीट करण्यासाठी ट्रान्सफॉर्मर काय करेल, काहीतरी एक्स्ट्रा अमाउंट ऑफ करंट प्रायमरी कडून घेईल. सो दिस एक्स्ट्रा अमाउंट ऑफ करंट टेकन फ्रॉम द प्रायमरी इट इज इक्वल्स टू I2 डॅश, and this current it is nearly equal to that of secondary current. Secondary current च्या इक्वल असेल, but it is in opposite direction, right? So see, if it will be flowing from primary, again तो प्रायमरी मधून फ्लो झाला की it will also set up some flux. तो पण काय करेल, काहीतरी फ्लक्स सेटअप करेल, that is flux phi2 it will be set up due to this additional amount of current I2 dash, right? But it is in the direction that is same direction as that of main flux. Main flux च्या same direction ना तो काय होतोय, प्रोड्यूस होतोय. Due to that it will neutralize the effect of flux produced by phi2. phi2 मुळे होणार, phi2 मुळे जे काही फ्लक्स प्रोड्यूस होत आहेत त्याचा इफेक्ट ते काय करेल, न्यूट्रलाइज करेल. ओके, so if the effect it can be neutralized, whether there is any distortion in the main flux, इफेक्ट जर न्यूट्रलाइज केला तर मेन फ्लक्सला डिस्टॉर्शन असेल का?
No, sir.
No distortion, no. So that is resultant value of flux, it will be only remains in the transformer. Transformer मध्ये resultant value of flux फक्त राहील. So at that situation the transformer take a primary current I1, it is the vector sum of these two current. या दोन current ची vector sum असेल. So we have represented these two current, this current I1, it is the vector sum of I1, it is the vector sum of no load current I0 plus additional amount of current taken from the supply, that is I2 dash. Okay, so at that situation this operation it is similar as that of no load condition, because in case of no load condition the current taken from the supply it is also vector sum of two current, and in case of load condition the vector sum of current taken from the supply it is also sum of two component. दोन component ची sum आहे. नो लोड मध्ये पण आपण दोन component ची sum बघितली. So that effect of or final conclusion is that whether the transformer it will be on load condition, whether the transformer it will be on no load condition, the operation remains same, right? Now getting, hello?
Yes, sir.
Okay, now see, we want to derive this equation. Equation derive करायचे. See, the flux phi2 it will be set up, flux phi2 जे आहेत current I2 मुळे सेटअप होत आहेत. So phi2, and it is flux produced due to that of secondary current, it can be neutralized by that of current flowing from primary. Primary मधून फ्लो होणाऱ्या करंट ने ते काय होत आहेत, न्यूट्रलाइज होत आहेत. That means it will produces a phi2 dash flux. So since both these flux are equal but it is in opposite direction, since phi2 it is equals to phi2 dash, right? Phi2 it is equals to same in magnitude but it is in opposite direction, then only we can call it as a that means we can call it as a effect it should be neutralized. बरोबर, त्याची मॅग्निट्यूड सेम असेल आणि अपोजिट डिरेक्शन नसतील तरच आपण त्याला म्हणू शकतो की ते न्यूट्रलाइज करतोय इफेक्ट किंवा कॅन्सल आउट करतोय. बरोबर, राइट? नो, okay, see this phi2, do you know that the flux is nothing but number of turns of that winding and current flowing from that winding. फ्लक्स कसे प्रोड्यूस होतात, किती नंबर ऑफ टर्न्स आहेत and किती अमाउंटचा करंट फ्लो होते. So that it is the multiplication of N2, that is nothing but secondary number of turns, and the current flowing from secondary side, that is N2 into I2, and phi2 dash flux. Phi2 dash flux कोणत्या करंट मुळे प्रोड्यूस होतोय?
I2 dash.
I2 dash. Okay. And how many number of turns is there? कोणत्या वाइंडिंग मध्ये प्रोड्यूस होतोय? प्रायमरी का सेकंडरी?
Primary.
So that means number of turns at the primary side is nothing but N1. So equation N2 I2 it is equals to N1 I2 dash. N2 I2 it is equals to N1 I2 dash. I want to calculate the value of I2 dash. So I2 dash ची value calculate करायचे. This N1 it can be shifted to that of this side. So it becomes N2 divided by N1 into I2. N2 divided by N1 into I2. So according to this I2 dash it is equals to, what is N2 divided by N1? N2 divided by N1 काय असतं?
Okay.
N2 divided by N1 it is nothing but transformation ratio K, no? So that the equation becomes I2 dash, that means additional amount of current taken from the primary, it is equals to K times that of I2. K times that of I2. So this equation it is important by solving a problem. I2 dash it is equals to K I2. Okay. And I1 is equals to काय आहे? मी इक्वेशन सांगितलं तुम्हाला. I1 bar is equals to I0 bar plus I2 dash bar. Okay. Now see, if I want to find the magnitude of this I1, so I1 is equals to under root of square of these two term, that is I0 square plus I2 dash square. So similarly here I0 is equals to, I0 ची value माहिती आहे तुम्हाला, where I0 is nothing but no load current, it is nothing but under root of I mu square plus IW square. So these are the some equation regarding this load condition. Load condition चे transformer चे काही equation. This is useful while solving a problem. Okay. I hope you all are understood this concept. That means what is the conclusion and what happen or what is the behavior of the transformer when it can be putted on no load, when it can be putted on full load. So the phasor diagram of same we will draw in the next lecture. Is there any doubt? याच्यामध्ये कोणाला काही डाऊट आहे का? हॅलो, hello, give me reply.
No, sir.
Okay, so in this way we will conclude this today's lecture and we will stop here. Thank you.